Today, you are going to learn how IoT objects can be connected to build up a human-centered decentralized SIoT network which provides best fit recommendations to the end user. Hi, my name is Daniel and I will present you together with Panos and Dimitris DANOS. Let's build up the scenario first. Imagine you had a stressful day and want to relax in the evening and watch a movie. Because you aren't a movie expert, you need some help to find a good one for you. You start for looking in a platform like Netflix where you get some recommendations. But this platform limits on provided content. You can also get information about new movies through newsletters or advertisement. But do you share their opinion? Last, you can ask around, which costs a lot of time. Are there some better ways to find a good movie? Imagine you have an IoT TV. Is there a way to find a good movie for you by asking other IoT TVs? And hopefully without slowing the network down because your request generates a lot of network traffic. Let's try to solve this in the area of SIoT that promises a more human-centered point of view and seamless interaction of humans and smart things with the social framework. Imagine instead of having only a smart TV, you have a TV which digitally represents you, like a digital me or an object that can find the best information for you. But before we started, let me show to you our motivations. Why we created DANOS. If you have Netflix own your data and learn patterns about you. And you cannot use it on Disney Plus, for example. So, how we build up a single profile from you on your device to increase the data privacy? How can a digital me of you have also the same behavior as you in the real world to be human-centered? How can architecture be scalable with billions of IoT devices? Based on this motivation, we built a framework, DANOS, which is a combination of our names, Daniel and Panos. Dimitris joined later. Now, let me transform you into a digital me running on an IoT TV, which has the task to find a good movie for his human. First, you need to search and find a location in the IoT network, where the probability is the highest to find good answers. Second, you want to establish relations with the most similar ones that you can certainly ask them about good movies to build up recommendations. But how is your anatomy as a digital me defined? You inherit attributes from your human, like age, gender, and so on, but also the personality traits. And you don't have only these attributes, you gain a human-centered behavior based on the big 5 personality traits. Every combination of personality characteristics will generate a number of behaviors. For example, the approaching behavior may relate to an extrovert, so you crawl for friends more time than other, regarding your human, which has also more friends on Facebook because he's strong extrovert too. Okay, now you have the characteristic of your human, but you have also a task, an intent to find a good movie for your human. So, you know preferences and the rating history of your human, what he liked and don't like. This is context related. So the preferences of the user feedback can differ if you are running on a fridge and your user asks you for the best beer. But let's don't talk the whole time about you because your human is waiting. Let's start to find the location where other similar digital me's are. So, you are entering the DANOS cyber world, a virtual location management framework, where other digital me's are registered. The DANOS cyber world is divided into areas, where each one represents an intent, and areas are divided into cells, which are clusters to reduce the communication load to find the most similar ones. You ask a schedule manager, which generates a traveling route for you that you can register on the most promising cells to crawl for new friends. Usual clusters will be generated through a global knowledge or a godlike perspective about each dataset. But in the concept of DANOS cells, a cell is completely detached from the surrounding cells and area to be scalable and have better data privacy because your data will only be shared in the cell where you are registered. Okay, but how does it work to generate the cell cluster? A cell has a memory of profile information from previous successful generated movie recommendations. This memory will be accumulated to a single proxy, which will be used to calculate the similarity between your profile and the cells to find the best one for you. After you get the address from the schedule manager for the best cells, you register in the cell and ask the cell for a new friendship. The cells relationship manager calculates the similarity between you and all other profiles. And you will go into a friendship with the most similar other digital me's, which means that you will share your direct communication channels with them to ask them later for a recommendation. But wait, there was a human-centered behavior introduced at the beginning. Because you have the personality traits from your human, you will manipulate the similarity metric in a human-centered way before you decide to go into a friendship. For example, you are risk avoiding. This means you only go into a friendship if the similarity is really strong. Here you see the formulas for the different behaviors which manipulate the similarity metric. Now it is time to ask your new friend for the rating history to build up the recommendations. You are getting the rating history from your friends. And you already know the similarity metric from the relationship manager. So it is really easy to build up the recommendations for your user by using the similarity metric and the rating history from your friends. Now you can provide your calculated recommendations to your human. And if he is happy about it, the profile information will be feedbacked to the memory of the cell, where it will use in the calculation of the proxy that other objects can make use out of it. Let's see how the evaluation looks like. To visualize the process and evaluate the algorithms, we built an UI to show how the digital me's are traveling. In the center, you see a map. The map is divided into squares, which are the cells, the clusters. Each dot represents a digital me, and you can see how they are traveling over time. And if I click on the heat map on the right top, I get some insights about the data in the cluster through the cards below. Over time, I can see how these clusters are specialized more over time. On the left side, you see general information about the digital me's. Let us observe the traveling behavior with intelligent traveling and without. Intelligent traveling means that we are using the proxy of the cell to find the right cell. With intelligent traveling, you see that the schedule manager will send you back to the same cells over time. If you see another digital me, which is in some part similar to you, but not overall, you're having some overlapping cells at some point. But the traveling route is different. And without the intelligent traveling, it is, how expected, really random. Let's take a look more into details. For the simulation, we simulate 2000 digital me's and run one simulation with intelligent traveling and one without. The memory size of a single cell is 30 and we are using 400 cells. Each simulation will stop after 240,000 object activations. On the left you see with intelligent traveling and right without. The dots are the similarity metric for the established relationships. You can see that the density is much higher on the left side, which means stronger clusters. Also, the left side generates 56% fewer friendships, which reduce the network load. The quality of the relationships are 5.8% higher because only the most similar digital me's come together. To observe the performance more, we created 1000 digital me's, and for each one we created an exact clone. Now we want to see how long does it takes till each one has found his exact clone. With intelligent traveling we are 110 times faster and generate fewer resources. Just looking back to the motivation, here you can see some conclusions and added values. We have managed to adopt a human-centered behavior to the objects, increasing the quality of the recommendations and maintaining the privacy of the user data among other benefits. Thank you and have a nice day.